Okay, we're unboxing a new shop vac for the mill. This way I can get this one just absolutely filthy, and not that it wouldn't get filthy the rest of the shop, but it's my own. Don't touch it. Nobody can touch. Don't touch. That's it. Now you're gonna have to clean it too. I don't really know how this goes together, so you can watch me struggle as we assemble it. It's a day in the life. Is that where they go? But they don't like, we should look at the instructions. I don't really want to, but.
Hey guys, welcome to today's video and Happy New Year. We're starting here 2022, January 3rd. Super busy. We're behind on orders, which is both a good thing and a bad thing, so we're working super hard to get back caught up, and my daily tasks continue where I need to finish developing and designing some parts that I had been halfway through at the end of the year. So for this video, I'm going to show you what I'm doing with the CTSV front suspension, front angle kit design. So I've got it off the car and I'm just going to start taking it apart on the floor so that I can target up the parts and 3D scan them. You guys have seen me do this before if you've watched the other videos, but I'll give you a quick sped up version of what I'm doing with that. So I've got the parts removed from the assembly and I had to clean them up a little bit because they have some grease, some oil, some stuff on it, and my targets here don't stick to that very well. What I have in front of me, when I do scanning, I like to do as many parts as I can at a time because the setup time is a little bit time consuming. So I actually have, this is a 96 to 99 E36 M3 knuckle, which has specific trail geometry that's different from the other years of BMWs. And I'm gonna scan this as well, and we're gonna be making different adapters and different knuckles for the BMW chassis. That's on a different project, but I'm just gonna scan that while we're here. And then for this, I need to stick the targets on. Because it's aluminum, I was able to use magnet targets for this, but I have to use the sticky adhesive targets for these arms. So it's gonna take a little bit. We'll probably just speed it up for you, but this is how you do it. Okay, so once we've completed the scan process, we now need to extract the critical dimensions from the scan file. So here you can see that I have the mesh loaded into my CAD software. We're using Fusion 360 in this case, and I have loaded in two files. One contains the critical dimensions, and the other one contains the mesh. Those are two different things. The mesh is what you can see here, which looks like the arm. This is actually not a physical part. This is just overlaid on top of my critical dimensions, which are essentially the bushing placements, the ball joint placement. I've already designed the stud that we're going to be using there. The shock points. I get the general shape of the arm from the mesh itself. So I like to start with the most complicated part of the project, that being, in this case, usually the arm is the easiest, but in this case the arm is actually the hardest because of this dramatic swoop. The tie rod actually passes over the control arm. Front of the car being on this side, so it's a front steering rack car. Tie rod passes over top, so we need all this clearance on our new arm. But the problem is the wheel contacts the arm here super early, and the width of the arm limits the amount of angle that we can get out of the steering knuckle. The length is too short. We've got a lot of problems to solve with this. So I have already done the design. The process is quite lengthy, and I'll just make the components appear from what I came up with. And you can see that we were able to create a lot more clearance for the wheel. So when you turn the wheel wants to come a lot into this area, and we have created that clearance by doing a much bigger swoop, I would say, so that the wheel has a lot of space to fall into. We also added 35 millimeters on the overall length. Where the ball joint is here, we're going to be welding our bearing out here. And the pieces go together relatively easily. We'll be using welding techniques to join everything together. I did a load analysis on the arm, and watching the strain path, I added this gusset. What's going on here is that there's a lot of force being applied at this end of the arm, both upward and back. So it really wants to pull through the arm, pulling on this mount, and it's kind of trying to twist this upright. This is, again, it's at a large amount of force, so we're building these arms to withstand 3, 4, 5 times the expected load that it would see. So that's what this gusset's going to be doing. It's going to reduce the flex in the arm, which flexing over a couple times isn't going to do anything, but flexing hundreds or even thousands of times back and forth may disrupt the weld point. So this is going to eliminate that flex. Going on, because this is going to take a while, the front upper control arm I actually am in the process of doing. Maybe I'll show you guys the process on doing the front upper, but it's actually super easy. This is with no design at all. I have my points, my bushing widths, the location. Basically, you don't need to do a whole lot with the upper with this kit because extending the lower is going to give us camber. And since we want to be running around -4, -5 degrees of camber, you're probably going to be leaving the upper control arm the way it is. We're going to do the design so that we have it on file and that we have the parts required, but it's not priority for me right now in the testing process. And then lastly, but certainly not least, this is where all the magic happens when it comes to the handling performance of a car. All of that is done within the knuckle. And with this chassis, more specifically because we're not going to be selling a ton of these kits, and it is a fairly rare and expensive car. It's a 2015 plus CTSV. So we're using the OEM knuckle, and we're making an adapter that corrects the Ackerman and steering ratio of the car. So as you can see, the mesh file is giving us the shape and design of the knuckle so that we can see interference points, we can see other things. But I have mounted the adapter bracket and designed it fully to the knuckle, and I'll show you that here once I select the body. So I can use critical dimensions that I have here. These basically give us the dimensions of these holes exactly as they were scanned. So I had a number of ideas for doing this. My first idea was going to be making a faceplate that uses the face of the knuckle and brings material over here so that I can weld parts to it and relocate the tie rod that way. But the rotor, because the rotor offsets back a little bit, the rotor would actually be hitting a plate if it came down straight, so that pretty quickly eliminated that. So the design then went to using the only 2 holes I really have available, which is the original tie rod mount location and the lower control arm mount. The 2 mounting points are on different planes. So this adds a little bit of complication, a little bit of designing, but that's what this software is so good for. I can create planes, I can project geometry, I can do a number of things using all of these functions to get these plates to line up perfectly. Now, this isn't the final product. This is basically a proof of concept, will it bolt up? And as you can see here, we actually need to remove a decent amount of material out of the knuckle. So I actually went ahead and made a traceable template for cutting, which is going to look something like this. So in the CAD software, I know that I need to cut on this line, and then for like the consumer, I would simply send them this worksheet. I'll give them a picture of the piece in its place here, but I will basically send them with this PDF, and they will be able to line this up using reference points on the knuckle, and they will be able to use a marker, mark on the lines, and then it says cut the knuckle on these lines, so they'll be able to take a zip cut, a bandsaw, or whatever cutting device they have, Sawzall, and remove this material here so that they can install the adapter, because this is where that hole needs to go in order for us to get 60, 65 degrees of angle, in order for us to have a much lower Ackerman, still slightly positive, but much lower than factory. That's where the hole's got to go. So we got to do a little bit of chopping, not a big deal. If you're doing any modifications on CTSV for drifting, chances are you're going to be okay with doing a little bit of custom work, because that car is already hard enough as it is to get aftermarket parts for. So I'm hoping this video wasn't too blurry or anything, because I don't do this stuff very often. We are going to be doing our first initial test. We're going to throw it on the hoist, we're going to build this kit, we're going to install it, verify the adjustment ranges, verify the alignment specs, verify everything else, and then test drive it. Going on a rant here. Thank you guys for watching. If this is the end of the video. It's been a long day, it's been a long week, and we'll see you guys on the next video.